The National Labor Relations Board's Occupation Outlook Handbook puts the average base pay for an experienced database developer at a little over $117,000 per year. Data is the lifeblood of modern business decisions, but it's meaningless without the ability to extract the right insights at the right time. And that is where SQL queries come in. They are your key to unlock all of the stories hidden in millions of rows of data. But if you've never used SQL before, I've got you covered with this step by step guide to help you set up your very own SQL environment. Just click this link to watch my video where I walk you through setting up everything you need to follow along and start building your SQL expertise. I'm certified in SQL Server, and in this video, I'm going to show you everything that you need to write real-world queries that provide the insights that companies value. A SQL query is your way of having a conversation with a database. Think of it as writing a very specific request using SQL's special vocabulary. This is the basic syntax of a select query. You select column names from one or more tables. Imagine having a magic key that can unlock all the valuable insights hidden within your database. The SQL SELECT statement is that key. It allows you to specify the columns and the data that you want to retrieve from your database tables. Whether you're pulling up customer information, sales data, or employee records. Want to get the most out of this tutorial and write these SQL queries yourself? I prepared all of the sample code we'll use in this video. Head over to my GitHub page linked in the description below. You'll find the complete group of sample queries we'll cover today. Just click the green code button and select Download Zip to get started. Make sure you have the files ready to gain the hands-on experience that will deepen your understanding and refine your skills. Let's get started. If you want to select all of the columns in a query, you can use the asterisk wildcard character. Using this might seem convenient, but it is often not performant and considered a bad practice for several reasons. It retrieves all the columns from a table, which can lead to fetching unnecessary data, increasing the load on your database and network. It slows down query execution times because it takes longer to get the data that you're asking for. It can consume more memory and again affects overall system performance. And if columns are added or removed from tables, it could cause potential errors. You really should be specifying the exact columns that you need. But what if you have never worked with a database before? Knowing what columns to include in your select statement means getting to know the tables that you are working with. The top expression is used to limit the number of rows returned by a query. It's especially handy when you need to deal with large data sets, but only care about the top few results. The basic syntax of a top expression is to return either the top number or percent of specific columns from any number of tables. The top expression quickly hones in on the most relevant data without sifting through thousands of rows. It's perfect for reports and dashboards where you need to highlight top performers or recent entries. It can also be used to get a glimpse into a table definition by limiting the rows that are returned in your query. This allows you to easily and quickly discover the tables that you're working with and what columns are required for a particular use case. To select specific columns from a table, you simply list them after the select keyword. Here, we're selecting the first name and the last name columns from the Human Resources Employee List view. SQL aliases are temporary names given to columns or tables within your query. They make your queries more readable and your results easier to interpret, especially when dealing with complex expressions or joined tables. They allow for clear, concise names, making complex queries easier to read and understand. They shorten long table or column names, reducing typing and potential errors. And they also provide meaningful names to derived columns or complex expressions, enhancing the clarity of your results. There are two types of SQL aliases: column aliases and table aliases. Let's take a look at how to use both of them. Let's start with a basic example using column aliases. This query renames both the first name and last name columns in the result set. The as keyword is used to assign aliases. With column aliases, you can effortlessly rename columns in your query results, tailoring them perfectly for your Power BI reports or Excel workbooks. No need to tinker with labels in those applications. Just set your aliases right in your SQL query and enjoy clean, readable data that's ready to shine. When working with multiple tables, like in joins, table aliases allow you to assign a new name to a table, often used in joins. We have two tables, employee and person, and we want to join them. This query assigns E as an alias for employee and P as an alias for person, making the query more concise. Aliases can also be handy when performing calculations. Let's say we want to get the years of employment for each employee and display it with an alias. Here, we are calculating the difference between today's date and each employee's hire date in years. We are naming the calculation as years of employment. Nested queries or subqueries can also take advantage of aliasing. For example, if we want to find people that are employees hired from 2010 onward, we can use aliases in both the subquery and the main query. In this example, date of hire serves as a handy alias for the hire date returned in the subquery, making our main query more intuitive. And don't worry if nested queries or subqueries seem a bit complex right now. We'll unravel all their secrets in upcoming videos. SQL join clauses are used to retrieve data from two or more tables based on a related column between them. This feature allows you to consolidate information spread across various tables, making your data analysis richer and more insightful. They are your magic connectors, enabling you to combine data from multiple tables into a coherent, comprehensive data set. Thus far in this video, we've kept table joins simple, only using one type, the inner join. There are several types of joins, including inner join, left join, right join, full outer join, and cross join. Now, let's explore how to use the different types of joins and see them in action. First up, we have the inner join. This type of join returns only rows where there is a match in both tables. We want to get a list of phone numbers for all employees in the marketing department. We get each phone number by joining the employee list and the person phone table. We identify the type of phone number by joining the person phone and phone number type table. The on expression is used to specify the condition that links the tables. It defines how the tables relate to each other by matching columns from each table, ensuring that the correct data is merged. Next, let's look at the left join, also known as a left outer join. This join type returns all rows from the left table and the matched rows from the right table. If there is no match, the result is null on the right side. For example, if we want to see which people in the person table are not part of the employee list, we would use a left join. Left join ensures we get all people, even if they aren't an employee. Any missing employee information will show as null. This join type allows auditing employee records for completeness, ensuring all employees have proper personal information on file, and identifies gaps in HR data that needs attention. The right join clause, also known as a right outer join, is used to return all records from the right table and the matched records from the left table. If there are no matches, the result is null on the left side. This ensures that all data from the right table is included in your results, giving you a comprehensive view. We can return the same results as the left join by reversing the positions of the tables and using the right join type. This query shows you people who might be vendors, customers, or contacts, but not employees. The complete roster of people in the database and their relationship with the company. Potential data inconsistencies where people records exist without corresponding employee records. Now let's talk about the full outer join. This join type returns all rows when there is a match in either the left or right table. If there is no match, the result is null from the non-matching side. Suppose we want to list job candidates and employees, even if there's no match between them because a candidate was not hired. Full outer join returns all rows from both tables. The full outer join is valuable in this case because it provides the complete universe of records for the hiring process. Imagine you have two data sets and you want to combine every row from one table with every row from another. The cross-join clause is your perfect tool for this, creating a matrix of the two tables and unveiling all possible combinations. This approach can be useful for exploratory data analysis, simulations, or generating comprehensive reports. It's ideal for scenarios where you need to analyze all potential interactions or combinations in your data. Here's an interesting example that shows what happens when we cross-join the shift in department tables. Every department is paired with every possible shift, all potential combinations of where and when work could happen, the full universe of department shift possibilities. While other joins match records based on related columns, cross-join says, show me everything paired with everything else, no conditions applied. It is time to practice those join skills. Here's your mission. Join the person table and the email address tables. Display the person's first name and last name columns. Display the email address's email address column and alias it with a column alias of email. The join chapter contains everything that you need to be successful with this hands-on exercise. But are you stuck? Drop me a comment and let's figure it out together. The where clause is used to filter records. It allows you to specify conditions that data must meet to be included in a query's results. Whether you're using comparison operators, logical operators, or pattern matching, mastering the where clause will help you retrieve exactly the data that you need. You can precisely target that data without sifting through irrelevant information and improve query performance by reducing the volume of data processed. In this query, we're capturing the first name and last name columns from the person table. By leveraging its relationship with the employee data history table, we can effortlessly filter out all records where the associated department name is sales. Operators are used in the where clause to define a condition to test a single expression or test between two expressions. Next, let's explore some of these operators. Comparison operators allow you to filter data based on conditions like greater than, less than, and not equal to. In the previous query, the equals operator is used to test for equality. It is a comparison operator and tested between two expressions, department and sales. Do you want to uncover which employees are earning over $50,000 a year? Just use the greater than operator in your query. It's your tool to filter out those high earners with ease. With this simple yet powerful operator, you can swiftly identify the top paid talent in an organization. Or do you want to spotlight employees who joined the team since 2011? Use the greater than operator with a date to filter out those new hires. This trick ensures you can easily find and celebrate the fresh talent that's been boosting a company's success. And if we want to find employees who are not in the production and production control departments, we use either version of the not equals to operator. Both of these operators test the condition that two expressions are not equal to each other to filter out specific values in a query's results. The between operator is perfect for narrowing down your data based on a range of values, whether it's dates, numbers, or any other scalar values. When used with dates or numerical data, it provides a clear and concise way to filter results. It is easy to use and understand, making your queries clean and straightforward. Suppose you want to find employees who were hired between January 1st and December 31st of 2011. Here's how you can achieve this using the between operator. In this query, the between operator filters the results to include only those employees whose hire date falls within the specified range. This makes it incredibly easy to narrow down your search and focus on employees hired within that time frame. Pattern matching is another powerful feature of the where clause. Using the like operator, you can filter data based on patterns. For instance, to find employees whose job title contained the word manager, we'd use the like operator with a wildcard character. The two wildcard characters that can be used with the like operator are the percent sign or the underscore character. Using the percent character, you can find any string that contains, starts with, or ends with a specific pattern. The underscore character is used to match any single character in a string, making it perfect for those scenarios when you need to find entries with just one variable character. It is for when you know part of the data, but need to account for slight variations. In this query, the underscore wildcard character represents any single character. You're searching for employee names and want to find all first names that start with a J and have exactly 3 more characters. Here's how you can make that happen. Each underscore character represents a single letter in the string. The in operator simplifies your queries by allowing you to specify a list of values to compare against a column. The list instantly filters your data to show only the rows that match your specified values. It reduces the need for complex nested conditions, streamlining your SQL code. Let's say you want to find employees who work in the marketing or sales departments. Here's how you can use the in operator to achieve this. In this query, the in operator is used to filter the results to include only those employees who belong to any of the specified departments. SQL logical operators are used to combine two or more conditions in a SQL statement's where clause. They allow for more complex and dynamic filtering by evaluating multiple expressions and returning results based on the combined logic. They enable you to filter data with pinpoint accuracy, ensuring you get exactly what you need. And they allow for dynamic query construction, handling a wide range of scenarios easily. The AND operator is used to combine multiple conditions in a where clause, ensuring your results meet all specified criteria. Only records that satisfy every condition will be returned. Multiple AND conditions can be chained together. This ensures your query results meet every single condition you specify, making your data retrieval highly accurate. This query is asking to see all employees that work in the marketing department that make at least $60,000 a year. Each condition acts as another filter, narrowing down your results to exactly what you need. And here's a useful tip. When using and, put the most restrictive condition first. This can help your query run faster since SQL can eliminate more rows earlier in the process. Just remember that all conditions joined by and must be true for a row to be included in your results. If even one condition is false, that row gets filtered out. The OR operator is used to combine multiple conditions in a SQL query's where clause. It returns true if any of the conditions are true, making it perfect for situations where you want to include records that match one condition, another, or even both. This ensures your query captures all relevant records by meeting any of the specified conditions. Suppose you want to find people who either live in the state of Washington or in Canada. Here's how you do it. This query is specifying that the state must equal Washington or the country region code equals the short code for Canada. You can also create more sophisticated logic by combining OR with parentheses. Parentheses help control the order of operations in your query, making sure complex conditions are executed in the right sequence. This ensures your results are accurate. Without parentheses, SQL might not interpret your conditions as you intend, leading to incorrect results. By using parentheses, you ensure the OR conditions are grouped and evaluated together, giving you precise control over your query logic. We are grouping the department conditions together so that SQL will get a list of all marketing and sales team members first, then filter out employees who make less than $60,000 per year. Remember, with OR, your query will return rows that match any of your conditions. It's the SQL equivalent of either this or that. The SQL NOT operator filters out unwanted data. Think of it as your database's way of saying everything except this. Rather than telling your database what you want, NOT lets you specify what you don't want, which can often be more intuitive. For example, instead of listing all of the departments you want to include, you could say, show me everything not in the production department. The NOT operator combines well with other operators to create dynamic and powerful queries. You can also use NOT with other operators like in, between, and like. We're expanding our query to show me everything not in the production or production control department using the in operator. One common gotcha to watch out for is using not with null values. Since null represents an unknown value, not null doesn't mean everything except null. You'll need to use is not null for that specific case. A key thing to understand is that null isn't zero, an empty string, or a blank space. It represents the absence of any value. That's why we can't use regular comparison operators like equals or not equals with null. Is not null is SQL's way of finding real, concrete values in your data, the fields that actually contain something rather than just empty placeholders. The is not null operator can be combined with other conditions as it is in this query. This query says, show me all production department employees who have actually provided their phone numbers. One practical tip. If you're building reports or analyzing data, checking for null values first can help avoid surprises in your calculations later. After all, you can't calculate an average price if some of your price fields are null. The more comfortable you get with these operators, the more you'll see them less as technical syntax and more as a powerful language for having conversations with your database. They are the building blocks that can turn vague questions into precise answers. Now it's your turn. Using the Human Resources Employee List View, find all employees in the marketing department who were hired on or after January 1st, 2009. What operator should you use to return all hire dates starting with January 1st, 2009? Share your results in the comments. How many employees did you find? Remember, you have to execute the script in the sample code to create the Human Resources Employee List View. It was created to simplify the exercises in this video. SQL aggregate functions transform raw data into actionable business insights. These functions are essential for data analysis and reporting. This isn't just about numbers, it's about telling stories with data that drive real business decisions. Whether you're optimizing inventory, adjusting pricing, or planning marketing campaigns, aggregate functions help you see the forest and the trees. Good decisions are driven by data, but great decisions are driven by data that's been intelligently aggregated to reveal meaningful patterns and trends. You should keep in mind that aggregate functions ignore null values by default, except for the count function. Let me show you the kinds of SQL queries that turn raw data into critical insights. The count function is used to count the number of rows in a result set. Imagine you're running an e-commerce business and want to understand your customers better. With count, you can discover patterns that might otherwise remain hidden. Suppose you want to find out who your most loyal customers are. This query reveals not just raw purchase numbers, but also customer loyalty patterns, showing which product categories inspire repeat purchases. Spotting these patterns can guide inventory decisions, pricing strategies, and product development priorities. The most powerful insights often come from combining count with other SQL features like case statements, subqueries, and window functions to build a complete picture of your business dynamics. Using count effectively requires thinking both technically and strategically. What numbers would actually help you make better decisions? Sometimes the simplest count query can reveal the most important insights for a business. The sum function is used to calculate the total sum of a numeric column across all rows in a result set. Now, your e-commerce company needs to understand what products are performing the best so that you can adjust your inventory strategy or create targeted promotions for high margin products. Next, let's look at the average function, which calculates an average value. Rather than trying to make sense of thousands of individual data points, average gives us a central tendency that can guide decision making. This query returns the average order value by product category where the average order amount is greater than 50. Keep in mind that while averages are useful, they can be skewed by outliers. For more robust analysis, consider combining average with other functions like median or including count to understand your sample size. This gives you a more complete picture for making data-driven decisions. The max and min functions are used to find the highest and lowest values in a column, respectively. Your product manager needs to make critical inventory and pricing decisions. Let's explore how Min and Max can help uncover those valuable insights. You could tailor your sales strategies by region. For markets with high maximum orders but low minimums, you might implement minimum order values or offer volume discounts to encourage larger purchases. Min and Max help identify outliers, opportunities, and patterns. Let's analyze some data. Using the Human Resources Employee List View, calculate the average annual salary by department. Find the department with the most employees. What function would you use to do that? Calculate the annual salary range, the min and the max, for each department. How do your results compare? Share your insights. The order by clause allows you to arrange the results of your query in either ascending or descending order based on one or more columns, allowing you to organize your data in a meaningful way. By default, the order by clause sorts the data in ascending order, which means from A to Z for text or from lowest to highest for numbers or dates. The order by clause can also be combined with other clauses. In this query, we're ordering our employee list by department and then their salary from the highest to the lowest value. We've added the descending keyword to tell SQL to sort the annual salary in descending order. You can sort by any number of columns or calculations that is required for your query. We are returning revenue reporting by salesperson for 2014. And we are sorting the alias total revenue in descending order. We're using this query to demonstrate that you can order by calculations. We're ordering by the maximum total due for any order and grouping by sales territory name. In this query, we are adding the where clause to filter on the order date year. Combining functions with the group by clause divides your data into groups based on specified columns, and then the aggregate function operates independently on each group. For example, you might want to calculate average sales by region, total revenue by product category, or count customers by country. Aggregate functions are often used with the group by clause to group rows that share a common attribute and perform calculations on each group. The having clause is used to filter groups based on a condition similar to the where clause, but for groups. To demonstrate, we are grouping this query by customer ID and person type. Our aggregate functions are counting total orders, summing how much was spent, averaging that same amount, and giving a calculation of our last order date. The having clause is filtering our grouped query by only returning customers that have multiple orders. To recap, SQL aggregate functions like sum, average, count, max, and min are key tools for data analysis. By combining them with the group by and having clauses, you can perform complex calculations and gain valuable insights from your data. We've just written some SQL Select queries from the ground up, covering all of the components of a select query. By understanding how to use these components, you'll be able to write efficient and effective SQL queries for any use case. Are you ready to test what you've learned in your quest to gain SQL superpowers? Using the Human Resources Employee List View, find the top 3 departments by average salary. Show each department's number of employees, average salary, and the highest paid employee's name. only include departments with more than 5 employees. This one combines everything we've learned. Need help? Break it down step by step, and don't forget about joins and group by, or the having clause. You have just conquered the SQL Select query, and your journey is only beginning. Don't stop now. Practice those queries and experiment with everything that SQL has to offer. I hope this tutorial has given you a deeper understanding of SQL queries and how they can empower you to make informed decisions based on accurate and well-formed data. And if you're excited to learn more about SQL, I've got tons of tips, tricks, and tutorials coming your way. And if you have any questions or need further help, then drop a comment below and let's get the conversation started. Thanks for watching and taking one more step in transforming your curiosity into expertise.